Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at string manipulation using the parse and join commands. One of the great strengths of the basic language in general, and PowerBasic in particular, is that of string manipulation. And today we're going to look at two commands within PowerBasic that excel at string manipulation: the parse and the join command. We have in previous videos looked at the string manipulation commands to read and write data files. So let's assume for the moment that we have read the header from a file in from disk. And this particular header has a number of columns: a name, address, department, age, and division. Whether this is coming from a file or whether this is from data from inside your application doesn't really matter. What we're going to do first of all is we're going to read the data from this string into an array. Previously we've used the parse command within a for next loop to read the data into elements of the array. However, today we're going to use the parse command but not the parse $command. So first of all we will dimension an array to hold the data we're going to be pulling in. We're going to use the dimension command to dimension an array from 1 to the total number of elements within this header. We can determine the number of elements in this header by using the parse count command. The parse count command takes two parameters, the second being optional. The first parameter is the string you wish to look at, in this case strHeader. If you do not give the second parameter, it assumes that you're going to be using a comma delimiter, which in this case we are. So this will dimension our array header to have 5 elements for between 1 and 5. We're now going to read the data from this string directly into the array using a single line of code. And that line of code is using the parse command. It takes two parameters, the first being the string containing the data, and the second parameter being the array into which you wish to write that data. Since we have already dimensioned the array is already big enough to hold the data that's going in. So how do we know the data has actually arrived in the array? So let's print the array out to our log. Since we're going to be doing printing this array out a few times within this application, let's create a function to perform that task. A new function called listArray. This takes in a single parameter, which is a reference to the array itself. So we're using a simple for next loop to step through each element of the array. And we will then print that out to our log. So now that we have that in place, let's try running the application to see if the data has successfully arrived in the array. And there it is displaying on screen each of the 5 elements of the array: the name, the address, the department, the age, and the division. So now that we have very easily populated our array from the header string, what else can we actually do on it? Let's assume we want to insert a new column in, a new element of the array. First of all, we'll need to increase the size of the array, so we're going to increase it by 1 element. We can do that using the redim command. If we follow redim with the word preserve, it's going to preserve all the data that's currently in the array. If we did not use the preserve word, it would redimension the array, but it would be entirely empty. So we're redimensioning the array from 1 to the upper bounding of the array at the moment, plus 1. So the upper bounding of the array is 5. So we're redimensioning it from 1 to 6, again as a string array. So having made our array bigger, we can now insert a new piece of information into the array. So we're going to insert a new column header called payroll, and I want to insert that into the second position. We can do that using the array insert command. This will insert it into position 2, and that which was already in position 2 will be moved to position 3 will be moved to position 4, and so on all the way down the array. So to see how the array looks now, let's print this back out to the log. and we will call our function listArray once more. So we can see the original array as it stood at the top of the screen, and the new content of the array with the payroll as being the second element, and all the other ones have been moved down one. So since we have this information within the array, we have the option to do other things to the array itself. So what I'm going to do now is to sort the array from the third element onwards. So we will keep name and payroll as the first two, but everything after that I want to sort ascending. Again, this is very easy to do using the array sort command. It will start its sort at element 3. It's collating at uppercase, so it's case independent, and it's set for an ascending sort. And again, we're going to output the array to our console, so we can see the result of our sorting operation. If we run the code now, we will see the final listing is name, payroll, address, age, department, and division. So we have successfully inserted a new payroll column immediately after the name column and sorted the remaining columns into alphabetical order. So you can see the parse command, as opposed to the parse $ command, can be used quite easily to manipulate data into an array. The join command can work in conjunction with this. We're going to use the join command now to pull the data back out of the array and to put it back into a string. So we're going to make the header variable equal to the output from the join $ command. The join $ command takes two parameters. The first parameter being the array we wish to take the information from, and the second parameter is the delimiter you wish between the elements. So having populated the header variable, let's output that to the log. And if we run our application now, we will see we are now back to a straightforward string, which is comma delimited, giving us name, payroll, address, age, department, and division. So using these two commands, we have successfully taken a string which is delimited by commas, inserted a new value into the second element, and resorted the rest of the column headings. If you're using these commands to manipulate data from within a CSV file, you may want to wrap each of the elements in double quotes. This can be done remarkably easily. If we change the second parameter in the join $ command to be $CQ, this is an inbuilt constant to give you a double quote, comma, and then double quote. So if we run this now, you'll see your output is now successfully wrapped in double quotes. One of the challenges in handling CSV files is for embedded commas. The general standard for handling CSV files in which there are embedded commas is to use the double quotes to wrap each element containing a comma. We can simulate that on our header. So our header now contains the same number of elements, name, address, department, comma office, age and division. But the department column now has an embedded comma, so I've wrapped it in double quotes. I've put the double quote in twice so that the string itself will have double quotes round the department, comma office. If we run the application again, we'll see it handles it perfectly. We start off with department office, payroll is inserted, and it's sorted. And then in our output, the department office is in the double quotes with a comma between it. So we can cope with comma-separated variable files quite easily. Hopefully you'll find these two commands for string manipulation useful in your applications, but that's it for today. Thank you for watching.